In this video, we're going to be taking a look at the 2024 AP Physics 1 exam, the free response question number 4. So we have a pendulum here, that's a small sphere, and I drew a little bit here. We have the force of gravity pulling straight down, and it's got a couple different components. This little component that's slanted, horizontal, or tangential to its path is the thing that's causing it to speed up, slow down, and the thing that is doing work on the pendulum. So it says, the pendulum is now taken to planet X. The mass of planet X is the same mass as Earth, but the radius of the planet X is greater than the radius of Earth. The sphere is again brought to point A, displays theta from the vertical, released from rest, and swings through its lowest point at point B. The work done on the sphere by planet X between points A and B is Wx. So I said over here that the force of gravity equals gmm over r squared. If the radius is larger, which is an inverse square relationship to Fg, then the Fg is less, and then the work is the parallel force times the distance. So the parallel force is a component of Fg. Therefore, the work of X has to be less than the work of E, the work done on Earth. On the next page, there's kind of a lot going on here. So let me go ahead and sum it up. We got a couple things going on. We have the same exact situation. The new string is slightly elastic, and the length of the string may increase or decrease depending on the tension applied to the string. And then mostly everything is the same. The new pendulum is then taken to a different planet, planet Y, where the radius of the planet Y is the same as the radius of Earth, but the mass of planet Y is larger than the mass of Earth. Now it's asking in a clear, coherent paragraph length response may contain drawings, explain how Ty could be larger than Te or also could be smaller than Te. Now, I'm not quite sure if I articulated this exactly the way that AP would have liked, but I broke it up into the could be smaller section, and this is the way I did it. The increased mass would increase the Fg and G. So I made like a little note over here if this mass increased. And then which would decrease the value of Ty because it basically gets more force. And then if this effect is greater than the effect of the elasticity increasing the Ty, the period, then Ty would decrease. And then I show another thing here where the period of the pendulum is 2 pi, the square root of the length of the string, divided by G. And then if we had a larger G over here, then we'd have a smaller period. So I maybe could have added a little bit more detail, but that's the main idea involved in making the period smaller. Now, as far as making it larger, the elasticity would increase the pendulum's length, causing a decrease in the period. Actually, that's supposed to say increase. So causing an increase in the period. And this effect is greater than, well, definitely couldn't write on this one. So one than the effect of the increased Fg and G, then the Ty would be larger. So if we have 2 pi square root of L over G, if we increase this L over here, then we're going to increase the overall period if the effect of increasing this G doesn't basically counteract that one and nullify it completely. So it just depends on the effect of each one of them and the degree to which they affect it. But I think something along the lines of what I said follows the concepts that you would have to know or have to be able to articulate. The way I articulated them, especially with not writing some of the correct words, wasn't the greatest, but I think you get the idea. So hopefully you did well in that question. Thank you for watching and listening.